TruStability HSC and SSC series silicon pressure sensors by Honeywell. Welcome to the training module on TruStability HSC series silicon pressure sensors from Honeywell. This training module will introduce HSC and SSC series silicon pressure sensors, the key features, and applications. Piezo resistance of a semiconductor can be described as a change in resistance caused by an applied strain of diaphragm. Thus, solid-state resistors can be used as pressure sensors, much like wire strain gauges, but with several important differences and advantages. The high sensitivity or gauge factor is perhaps 100 times that of wire strain gauges. Piezo resistors are implanted into a silicon medium, and the implanted resistors are integrated into the silicon force sensing member. Silicon is an ideal material for receiving the applied force. It is perfect crystal and does not become permanently stretched. After being strained, it returns to the original shape. Silicon wafers are better than metal for pressure sensing diaphragms, and the silicon has extremely good elasticity within its operating range. Silicon diaphragms normally fail only by rupturing. These pressure sensors offer state-of-the-art benefits of hybrid IC devices, including compactness, ruggedness, and reliability. Each Honeywell solid-state pressure sensor is developed around a square silicon chip with an integral sensing diaphragm and 4 piezo resistors. Pressure applied on the diaphragm causes it to flex, changing the resistance, which results in a low-level output voltage proportional to pressure. The sensing resistors are connected as a 4-active element bridge for best linearity and sensitivity. Gold pads attached to the silicon chip surface provides connection to the piezo resistors and serve as pads for bonding of wire leads. The thin diaphragm is formed by chemically etching a square cavity into the surface opposite the piezo resistors. The new TruStability silicon pressure sensor offers different accuracies and compensated temperature ranges that address specific segment needs. These devices offer customers 3 benefits: stability. These sensors are the most stable silicon pressure sensors available. Accuracy. They are designed to provide an extremely tight accuracy specification. And thirdly, flexibility. These modular and flexible designs offer customers a variety of package styles and options, all with the same industry-leading performance. The TruStability silicon pressure sensors include HSC and SSC series. HSC stands for High Accuracy Silicon Ceramic, and SSC stands for Standard Accuracy Silicon Ceramic. The HSC series is designed to provide a plus or minus 1% total error band specification, and the SSC series provides a plus or minus 2% total error band specification. Despite their small size, both series are temperature compensated, calibrated, and provide an amplified signal, typically allowing the customer to remove the components associated with signal conditioning from the PCB to increase space and reduce costs often associated with these components. Both series offer the option of analog or digital outputs. Digital ASIC output in either I2C or SPI protocols from digital sensors accelerate performance through reduced conversion requirements and the convenience of direct interface to microprocessors or microcontrollers. These pressure sensors are designed to be used in a diversity of applications. They are ideal for applications requiring precise measurement of pressure, where the benefits of repeatability, low hysteresis, and long-term stability are important. In medical equipment, where accuracy is often critical, solid-state pressure sensors are used in airflow meters, kidney dialysis, handheld blood pressure monitors, oxygen concentrators, ventilators, and respiratory machines. In industrial applications, the broad sensing capabilities and ruggedness of these pressure sensors are well suited for use in barometry, flow calibrators, HVAC, and pneumatic controls. HSC and SSC series sensors measure absolute, differential, and gauge pressure. The absolute versions have an internal vacuum reference and an output value proportional to absolute pressure. Differential versions allow application of pressure to either side of the sensing diaphragm. Gauge and compound versions are referenced to atmospheric pressure and provide an output proportional to pressure variations from atmosphere. Note that the output type defines which protocol the sensor uses to communicate. Here are some key parameters to help you roughly evaluate these sensors. Both series look similar, but the total error band, compensated temperature range, and response time is slightly different. The compensated temperature range is the temperature range over which the sensor will produce an output proportional to pressure within the specified performance limits. Obviously, SSC series has wider range. The maximum deviation from the ideal transfer function over the entire compensated temperature and pressure range is called the total error band. These errors are caused by offset, full-scale span, pressure nonlinearity, pressure hysteresis, repeatability, etc. We can see from the table the HSC series has higher accuracy. If your application is more sensitive to response time, then the HSC is a better solution than the SSC. The simplified part numbering references the HSC and SSC series based on their package, pressure port configuration, pressure range, output type, transfer function, and supply voltage. The figure gives you the order guide. Hemodialysis machine treatments replace some kidney functions by removing waste and fluid from the bloodstream via diffusion and osmosis of solids and fluid across a semi-permeable dialysis membrane. This slide shows the simplified block diagram of a hemodialysis system. The HSC and SSC pressure sensors are designed to provide enhanced reliability and may be used to obtain a direct inline continuous dialysate and venous pressure measurement in the dialysis membrane without interrupting flow.